Let's do an example of linear programming, which is how we use lines to make feasible regions to answer real-life questions. The Fun and Games Company produces two kinds of water pistols, regular and long distance. Okay, I'm just going to start by saying we've got regular and long distance. Those are our variables. The company can make at most 600 regular. Okay, so the regular is going to be less than or equal to 600. I would always, when you're writing these inequalities, just stop and say, what does it mean? When I say I can make at most, does that mean I can make more or I can make less? Of course, it means in this case, you can make less. And 400, long distance. So same thing, I can make less than 400, but I can't make more. The total number that cannot exceed 900. So if I were to add these two together, it has to be less than or equal to 900. The next thing I want to do is graph these equations. It'll help me figure out the region of possible outcomes. So let's start with regulars less than or equal to 600. You can see I've chosen to put long distance on the y, regular on the x. Absolutely no problem in switching that. So let's start with this regular less than 600. So I'm going to come to 600, and I'm just going to draw a vertical line at 600. And since it's less than, I'm going to shade all of the stuff over here that's less than 600. Now let's do long distance. So the long distance less than or equal to 400. So I'm going to put a line at that long distance 400 spot like this. And then I'm going to shade all of the stuff that is below that line since it was less than. Now at this point, we have a rectangle that's kind of our feasible region. The rest of this stuff up here and over here is not going to be part of our solution set because it worked for one constraint but not for both. So we're down to this rectangle. Now let's graph our last constraint, and I'm going to do this using the intercept method. And by that I mean I'm going to start by saying, well, if I made no regular, so I'm just kind of blocking that. If I made no regular, that means I could make 900 long. Now, if you're thinking to yourself, well, wait, you said that wasn't possible. We graph each of these inequalities separately. The shaded region we make will take care of this kind of problem that I'm about to put a point at 900 long pants, even though I said I can't make that. But let me do that. I've got my 900 long pants right up here if I made no regulars. And if I made no long pants, I'd also make 900 regulars. Let me put that. And let me, as carefully as I can, draw this line. Pretty good. Okay. And we are less than that. So I could do kind of like this feasible region here. So now you'll notice that our feasible region is going to be this shape, this kind of pentagon right down in here. This is the spot that works for all of it. So again, the fact that I had these other constraints allowed me to kind of take care of the fact that like that last equation I graphed didn't necessarily work in the context of the problem. Okay, this is my feasible region. Now, the company can make $1 profit on each regular pistol and $1.20 on each long distance. Let me write that down. Our profit equation is $1 for each regular and $1.20 for each long distance. And we want to maximize the profit. Now, maximizing always occurs at a vertice. Because if you think logically about this, why would we choose to make less than we're allowed to make if we're trying to maximize our profit? So it's not going to be in one of these interior points. It's always going to be where these lines intersect. We're most concerned, of course, with the kind of perimeter, but specifically these spots where they intersect. So I'm just going to put a little highlights here, we've got 5 vertices. And there are a few of these I'm just going to kind of cross off because they don't make any logical sense. You are allowed to plug all of these in. For example, right here you could say, well, 0, 0 is a vertice of my pentagon. But if you're trying to make money, why would you make 0 regular and 0 long distance? Now again, you can plug it in. You're going to get 0. So to me, it's just not worth plugging in. I'm just going to scratch that one out. Next, let's go up here. Make 0 regular and 400 long distance. You could type that in, 100 times 0, 120 times 400. But why would you choose to make only 400 items when you're allowed to make 900? You can type it in your calculator, but to me, it makes no sense. Same thing down here. You made 600 regular, so $1 times that's 600. But you chose to make no long distance. Again, if you could make 900 items, why not make all 900 items? Scratch that one out. These are the 2 that we are actually going to be concerned with. Okay, this one where we made 400 long distance, so we made 500 regular, so 500 comma 400. And this one right here where we made 600 regular and therefore made 300 long distance. Now, just thinking about it, both of these things added up to 900 items. But if I told you we're going to make 900, and this is the profit equation, obviously you want to make as many of the more profitable ones as you can. So the correct answer here of how many of each product is this one. We should make 500 of the regular and 400 of the long distance, which should make sense. If long distance gives us more profit, we should make as many of those as we can. So again, when you're doing a linear programming question, start with your constraints. What functions limit what we can do? Graph those constraints and find the region that works for all of them. Then use the vertices to kind of guide you through your optimization or your equation to figure out which one is best. If this video helped you, please like and subscribe for more math help.